When I first got this, I didn't know that this post right there was not part of the original game. The plastic broke underneath, and somebody decided to just put a post in there so the ball won't go up and get stuck. And only once I started looking at it for a while did I notice it. No, that was a fix somebody did to get by. So we're going to fix the plastics. We're going to make some of our own. So first off, we have to design these, get the vector file going, and we're going to cut these out with a laser. This plastic is kind of rough shape. You can heat treat these. I don't know if I want to. We're just going to do the clear plastics first, and these with an image on it. We'll try and fix those later. But this is easy enough to get started with. You can see right there, it's busted. The ball comes up, hits it. After a while, it's just not going to hold up. So I'm curious, how many of you have this problem as well if you own this machine? It's also warped. You can see it's sagging. And the second one, there's only two with no graphics on them, is right under here. And this one's just yellowed. It's not actually broken. We'll replace it anyway. Fits in this slot, so the thickness on this one's got to be pretty close to the original. It can't be thicker because that was really tight. So what I plan on doing, trace it on graph paper, and that way once I scan this in or just take a photo of it, I can tweak the corners and make sure it's absolutely square. And I know that these are an inch grid, so it's going to be really easy to get the size and the scale. So now on this one, because I'm missing the piece, it won't be too difficult. I'll just continue the geometry here just based on the shape that it is. I traced a few, and there's the busted one. That piece goes on top. And there's our other piece there. Now with the image in Illustrator, I'll turn on my drawing. There we go, and you can see what I've added on. Now I'm curious, if you have this plastic and you want to send me a picture of what that curve looks like to the best of your ability, take a picture of it and send it to me. I'm curious to know what a non-broken one looks like, just in case my curve's off, I can compare it. But that's what I came up with. Now that we have the curves all ready to go, I'm going to export this file as a DXF, and we're going to take that into the laser cutting software, which is here. All right, well, let me introduce you to the laser cutter. Here it is, and this is the make block. It's a pretty nice machine. It's come down in price. I think it was $5,000 originally, and it's down to, I think, $3,500. Don't quote me on that. I'll put the link in the description. Those are US dollars. But shipping is going to be a little bit of money because this thing is really big and really heavy. It's all an enclosed system here. The cutting bed is, I'll do maybe a graphics overlay if I'm wrong, but I think it's about 500 millimeters here and 200 or 300 this way. And it has, let me show you back here. You see that glass tube? That's part of the cooling right here. It has a cooling because this gets incredibly hot, so it needs a cooling system. And so some of these cutters you might see, they have like hoses coming out into a tub of water that circulates the water, keep it cool. This one has its own like antifreeze water mix. There's a tank under here. You don't have to worry about it. It just goes on its own, so you don't have to think about it. There's a camera right underneath, and when you close it, it looks down. You put in your material, it looks down on your work, and that image shows up on your computer screen, so you can help place whatever design over your material that you want to cut. And let's see, this tray, people do take this out in case you want to put a huge sheet in here, so you can actually fit bigger materials. You just can't cut it all. This is kind of like, you might, if you know anything about laser cutters, compare this to the Glowforge. It looks really close, but it is different in several ways. The Glowforge, I think, has a full pass-through, so you can move material all the way through. That's kind of nice, but one of the big downsides on the Glowforge, I think, is the software has to connect to the internet to use it, whereas this doesn't. So this is the filter, and I've taken it out. Let me show you the filter here. Because it makes so much smoke, it has this big beefy filter here. Now I take it out because I want as much airflow as possible. When I'm cutting plexi, it really stinks, and if you have your computer or whatever in your office and you're sitting here with this, it's going to smell up the place. So you get better airflow. Now the problem with that is if you have neighbors or something or kids outside, you don't want to choke them to death with your smoke, especially wood really smokes up the place. So just gonna have to keep that in mind. Any other questions? I don't think so. So it's really big, really heavy machine, works really well, and we are going to send the image over here and put in our plexiglass as well, and it will cut it right out. Now it connects Wi-Fi, so I have my computer in the office over there. Let's put in some plexiglass. That's enough chatting. Here's a piece. Now I've done some test cuts with this already. And the tape is to stop it from moving around, because this has so much going on with the circulation pump, the fan, and this thing moving around. It is possible for the plexi to slide, and you don't want that because your cut's going to be all ridiculous. So this is just a little bit of tape there, just so it doesn't move while we're doing it. And I'll close it. Now the camera is going to go communicate over to the computer. Okay, yeah, it is 500 roughly by 300. That's the size that you can fit in the machine and cut it out. So I have right here, there's the graphic, the outline. And what it does is it cuts out the circles first, and then it cuts out the outside perimeter so that nothing's moving. Because if it cuts out the outside perimeter, there's going to be a gap of the cut, and then the inside might move around. So that's why it does it like that. Here we can see what it's going to do. It's going to be at a speed of 4, a power 50. So 4 out of 100. 100 would be 100%. These are just percentages. 100% speed is the max. So we're at 4. It's pretty slow. Power's cut in half at 50. Counts, that means passes. How many times is it going to go around and cut? Maybe you're doing something super thick and you just can't cut the whole thing through at once. And then you need to mess around and increase the passes. So let's hit go. So with this button there and the machine on, it's going to send it over. Estimated time to cut this out, 1 minute 9 seconds. We're going to hit send. And it says go ahead to the machine, push the button, and it'll start cutting. One tip with these cutters, when you're cutting certain materials, like if I cut through here and it hits this little metal honeycomb grid, it's going to, the laser will cause a flash and make these little burn marks in the back of the plexi. And so it's not horrible, but it bothers me. So I have a slightly damp paper towel I'm going to put underneath, and that will stop it from doing that. And you can also stand this off with some little pegs underneath so it's not actually on the metal table. So now I have to go back and send it, I think, because it thinks, hey, you just switched whatever you put in here. The height might be different. The material might be different. So I got to go back and confirm and resend it, and then we'll hit go. Yeah, let's give it a shot. So it's going to run for about, I don't know, you can program it to run for a different length of time. It's going to run for about 90 seconds or so, clearing out the smoke. And if I had my settings right, this should just pop right out. There we go. Look at that. Clean as that. That is awesome. I mean, to cut something out like this by hand, I've seen some people try it, and you know, they did as best as they could, but you just can't match a tool like this. Back to the computer. Let's delete that and import. Maybe it was this one. Let's drop that one on. Metric. There we go. And I think this settings, let's put on 2mm acrylic. And that was power 4, speed 50, if I recall. Sorry, speed 4, power 50. Okay. So we hit start, 1 minute, 10 seconds, send. You can see just how clean that cut is. I hope it's in focus. There we go. Maybe that's better in focus. Old, new. You can see just how discolored this thing is. Warped. And these posts, you're not going to find them. They don't make those. They're specific to these parts. So I just have these aluminum standoffs here. And those about the same size. So these will work just fine. And there's the old and the new. So this piece has to be an exact size to be able to fit in the wood. This one, I went and did, I had a scrap of 3mm plexi, a little scratched up, but this is going to be thicker than the original so that it will handle a beating right there on that corner a bit better. So I think I'll make these out of a thicker plexi just so it can last better throughout time. It's a little awkward because these things are going to move around on there. Okay, so 4 of those and the plexi on top. I wonder what the best way of doing this is. See if I can get them lined up first. A little closer. Guess you just do one at a time. That's probably the best. So just twist that one in by hand, and then I'll line this one up. Just through here, grab it on the plexi, then through the spacer into the hole. It's not so hard. Okay, just gotta move this one down. And one more at the very back. Yeah, I think we got it. That is nice. Man, I'm happy with that. This one goes in very easy. There we go. Well, you can't beat that. Man, it really bothers you to have busted up plastics on a pinball, doesn't it? You can see the thickness on this one. And I'll move over. You see the difference? This one is much thicker. That'll hold up a lot better. It's neat to have this actually function now the way it should. It actually hits the bumper. Before, it would hit this post and come down this way, but now, cool. Well, we're a little closer to finishing this thing. If you guys need some plastics, I'll put some contact info in the video description. And I don't know how much it'll cost to send in all that, but we can work something out. Also, if you guys do want a laser cutter, these things are awesome to have. I know they're crazy expensive, but I'll put a link in the video description for this as well. You can check out the info, specs, and all that on it. And they even make one now. I think the newer model has, you can take this out and it has a motor with some rollers in it, and you can like engrave on round things. So like, you know, water bottles, whatever, it'll spin it as the laser goes. It's kind of cool. This is the original model, but anyway, if you want to pick one of those up, it's an affiliate link, so it also supports this channel. Anyway, that's it, guys. Hopefully I'll see you sooner than later. I've been a bit busy, but this is always a fun project to get these things fixed. Take care, guys. Have an awesome day.